Okay, moving past transformations, which we did in class today, function operations and composition of function. This is going to be a lot of review. This is something that first, it's only one topic, and it's stuff that you have done in previous years. So let's look at this section. We're going to start with looking at operations on functions, which is simply adding, subtracting, multiplying, or dividing two different functions. It may be written kind of weird. I'm not sure if you're used to this notation, but if I want you to add f and g, I may write f of x plus g of x, or I may write f plus g of x. They're the same thing. And same thing goes for any other operation. F minus g of x is f of x minus g of x, and you can read the rest. So that's what those notations mean. And here's some examples. All the way there. You need to pause that, maybe write some of those down. Yeah, okay. Examples of operations on functions. Here I gave you three functions, f, g, and h, and I want you to start by doing f of x plus g of x. Real simple. We're going to start with f of x, which is x squared plus 4x, and then we will add to that. And let's go ahead and stick these in parentheses. If I'm going to do f plus g, put them in parentheses because sometimes it's going to make a difference in how this works out. So here's what we get when I do f of x plus g of x. Then I look at that, and I'm basically about to rewrite the whole thing. And we see if this can clean up at all. Is there anything that combines, cancels, whatever? And in this case, there's not, so we actually are through already. That one was real simple. You just simply did f of x plus g of x, and you're done. Let's see, moving on. I thought I had another one right there. Oh, well, here they are. Okay, so let's try f of x minus h of x. Well, here's f, x squared plus 4x, so x squared plus 4x minus, so minus, and then I'll do h of x, 3x minus 5. Okay, this one, it looks like I may be able to do something. This is x squared plus 4x. Distribute the negative, minus 3x plus 5, and then we'll combine our like terms. X squared, 4 minus 3 is 1x plus 5. And we're done. Sometimes these will factor, but it doesn't matter. You don't need to factor this because you're not going to be able to cancel. I'm not asking you to do anything else with the answer. So we'll just leave it as the trinomial. F of x times h of x. Again, same. We're just going to do f, x squared plus 4x times h of x, which is 3x minus 5. I swapped the colors so well. So there's h. This one's f, and we're multiplying those. And I do want you to completely multiply this thing out. So a lot of your teachers do foiling. This is x squared times 3x. That's 3x cubed. X squared times negative 5 is negative 5x squared. 4 times 3 is 12. X times x is x squared. 4 times 5 is negative 20x. And it looks like we can combine. I can combine negative 5 and 7. Those two add to 7x squared, the 3x cubed, and the negative 20x just comes along for the ride. You could, if you really wanted, factor an x out of that. They do have an x in common, but factoring is unneeded here. So I'm just going to put a box around that and move on. H divided by f. So let's see, here's h. H is 3x minus 5 divided by f, which is x squared plus 4x. So I've written h over f. Now, I've been telling you not to factor, but when you have a fraction, it's a good idea to factor because sometimes you can cancel something on top with something on bottom. And I'm looking at my denominator, and I can factor an x out of that. So that'll be x times x plus 4. My numerator is 3x minus 5. And then I'll look at that and see if anything cancels. It turns out nothing canceled. So the factoring in this case didn't help us any. But it's a good idea in the case of rational functions, in case of these fractions, to go ahead and factor just in case something does cancel. And that's operations on functions, and that's about half of the lesson. How far are we in? 4 minutes. Okay. Composition of functions. This one's going to be a little bit more heavy on the algebra. This is when you stick one function inside another. So the notation, if you see FOG like this, I call it FOG, but really what that's saying is f of g of x, which means you're going to take the g function and stick it inside f. So this example right here, this is the exact same thing as saying f of g of x. And when you're doing functions or composition of functions, we start on the inside and work our way out. So it's f of g of x is x minus 4. So I'm going to take x minus 4, stick it in there, and now I need to do f of x minus 4, which means I take the x minus 4 and I plug it in for x in my f function. So this is going to be, f is x squared plus 1, but instead of x, it's going to be x minus 4. You just stick that in there for the x squared plus 1. And then you do need to multiply that out because things usually will cancel. So x minus 4 all squared, remember you have to FOIL that. That's x minus 4 times x minus 4, which ends up being x squared minus 8x plus 16. So that's what I got when I squared that out, plus 1. And then 16 plus 1 is 17. So x squared minus 8x plus 17. And I'm not going to bother factoring this because it's not a fraction. Nothing's going to cancel if you factor it. So I'm going to stop, and there's my answer. So that's what composition is, sticking one function into the other and then clean it up as much as possible. See, moving on, same two functions. If I wanted to do g of f of x, well, now I'm going to take my f function and stick it inside of g. So this f function is x squared plus 1. And then I will do g of x squared plus 1, which is going to be, g is, let's see, x minus 4. So in the place of the x, I'm going to stick an x squared plus 1. Minus 4 comes along for the ride. I don't have to square or do anything funky, so x squared plus 1 minus 4. 1 minus 4 is negative 3. So x squared minus 3 is our answer. Yeah? Yeah? All right, f of x. F of f. Well, now we're getting kind of crazy because I'm going to take the function f and stick f inside itself. So I'm looking at my function f, which is x squared plus 1. And I start on the inside. F of x is x squared plus 1. And then I need to do f of that. So now looking back at my f function, I'm going to take x squared plus 1, and I'm going to put it in the place of the x. So f of x is x squared plus 1, except instead of x, I put x squared plus 1. So it's going to be x squared plus 1. That took the place of the x. It's all squared plus 1. And then again, we're going to completely expand that thing out. So x squared plus 1 squared, remember you have to FOIL that. That's going to be an x to the 4th plus 2x squared plus 1. That's what you get when you FOIL that, plus 1. And then we combine like terms. X to the 4th plus 2x squared. 1 plus 1 is 2. And you don't need to factor that because it's not a fraction. There's nothing that's going to cancel, so I'm going to leave it. Good? 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 Let's see, f of g. Now this time it's of 2. I've stuck a number in here. It's not in terms of x. So this is saying f of g of 2. And I think these are a little bit easier because you actually get to manipulate, or you actually get to use numbers. I'm going to start on the inside, and I'm going to find g of 2. So over here on scratch paper, g of 2 just means I'm going to plug 2 in for my x. So that's going to be what? 2 minus 4. 2 minus 4 is negative 2. So g of 2 ended up being negative 2. And then I need to find f of that. F of negative 2. I'll plug negative 2 in for x right there. Negative 2 squared plus 1, negative 2 squared. What's your fancies? You square the negative also. That's 4 plus 1, which is the final answer of 5. Good, good? Good, good? Good, good? 9 minutes in. Yeah. We have a little bit more. We're going to add a little bit of a twist to this. So we're going to do the same thing. We're still going to do compositions. F, or this time it's g of f, but now I'm adding one little tweak to it and state its domain. So if here's f, and that's g, I'm doing g of f of x. So g of f of x. Well, f of x is square root of x plus 1. And then that means I need to take the square root of x plus 1 and plug it in for x up here. So this is going to be the square root of x plus 1 all squared minus 1. Now, what's important about these problems is you really need to find the domain before you clean up. And the reason is, if I were to clean it up first, the square root of anything squared is just whatever's under the radical. So square root of x plus 1 squared is x plus 1. Minus 1, x plus 1 minus 1 is x. So that's my final function. That's what g of f of x is. So I've done part of it. There's the function. This looks like my domain is going to be all real numbers. Because remember, with domain, we got to think what screws it up. And so far, we can only do domain, or we think about domain if you have a rational function, if you have a fraction, which is rational, or if you have a square root. And my final answer is neither a fraction nor it's a square root. So you may be thinking all reals, but when you're doing domain, you actually need to do the domain before you clean up. So do the domain of this thing. And in that function, before I started simplifying, I did have a square root. I had square root of x plus 1. And so I've actually got to find the domain of square root of x plus 1. And remember, with domain, that's a funny looking M. Let's fix that. There we go. With domain, if you have a square root, that means your inside must be greater than or equal to 0. And so when I solve that, I get x is greater than or equal to negative 1, and that's our domain. In interval notation, that's starting at negative 1 and everything greater, all the way to infinity. So my composition function is just x, but my domain is still negative 1 to infinity. So find the domain before you start simplifying, because otherwise you may end up tricking yourself into the wrong domain. Looking at the next one, again, find g of f of x and find the domain. So g of x is 5 over x. F of x is x squared plus x. So that's going to be 5. I'll do it this way. That's g of f of x is x squared plus x. And then I take that x squared plus x and I plug it in for x in the denominator right there. So g of x is 5 divided by, and then x squared plus x. And then I need to find the domain of that. Now here I have a fraction. Now the last one's square root. If you have a fraction, domain, remember the bottom cannot be 0. So if I'm going to find the domain, I'm going to go ahead and do the domain now. So let's do domain. If you have a fraction, that means your bottom cannot be 0. So x squared plus x, I'm going to set that equal to 0 and solve for x. Let's see. I will factor out an x. Leaves me with x plus 1. And then you set each factor equal to 0. And that gives me x's cannot be negative 1 and 0. On the number line, remember negative 1 is before 0. And that's what I cannot have. I can have anything else. So my domain here is negative infinity to negative 1. Everything between negative 1 and 0. And everything after 0. That's my domain. I put a bracket around infinity. How stupid is that? There we go. So there's my domain. Now that I've found the domain, I will go back to my function and I'm going to clean it up some if I can. This one, all I can do on the bottom is I can factor out an x. And it turned out nothing canceled. So this is your composition. That's your g of f of x. This is the domain. Just remember, find the domain before you start cleaning up. And there is one more thing I wanted to look at, but I'm going to stop here for the sake of time. We're at 14 minutes, and I don't want to hassle with this. We'll do some of these problems in class, but what we're doing is, for these, we are undoing the composition. So I'm giving you like F, H, and F. That's supposed to be H. And in the past problems, we actually put them together, and now we're going to take them apart. That's something we're going to do in class.